What's up, everybody? Okay, so I just need to know, is everybody doing great? And are we live? Yes, we are absolutely. We are live right now. Okay. So, what's up, everybody? This is me, Yawar Manzoor, and I hope everybody is doing great, nice, and absolutely fine. And I just want to know in the live chat how many of you are doing great. Come on. Okay, what's up? It's Teachers' Day today. Okay. And we will be talking about some of the beautiful concepts about the projectile motion. This is actually the lecture number 1 of projectile motion, in which we'll be talking about some of the beautiful previous year questions and what actually this projectile motion is, where does it come from, why do we study this, everything in detail with the feel, okay? And we'll be talking about the angular projectile, means if we throw something like this at an angle, we call that this is the example of angular projectile. That's what we're going to be talking over here. Okay, fine. So yeah, thanks. That's great. Now, before that, I need to tell you something about me. That is, my name is Yawar Manzoor and I'm from Kashmir exactly. I'm a JEE Physics expert. Piece of information about me, and I'm exactly over here, okay? Now, apart from this YouTube platform, we have our own platform. That's what we call the Unacademy's platform. Over there, basically, country's top educators are teaching you. Understand? Inside Unacademy only, okay? Some of the great mentors are teaching you over there. Now, if you want to learn from those educators, you want to boost your rank in your upcoming JEEs, so definitely I suggest you should take this plus and you should take this Iconic subscription, because there are so many benefits that you exactly get in this plus as well as in this Iconic. Like, you'll be getting live classes, weekly tests, structured courses, unlimited access. What does this unlimited access exactly mean? It means you can watch anybody's lecture any damn time in a particular category. Understand? This all comes in plus: weekly tests, live class, structured courses, and all. Now, if you take this Iconic subscription, in this Iconic subscription, you'll be getting all the benefits you get in plus, because this is Iconic, okay? All the benefits you get in plus, and there are some extra benefits as well. That is this personal guidance, this test analysis, experts guidelines, study material, study planners. What is this personal guidance all about? This personal guidance is nothing but an educator will be given to you. Understand? He'll help you throughout your exam, how you can crack it, what are the steps that you need to exactly follow. What are the steps that you need to exactly follow? We have launched so many batches in English language as well, okay? Yeah, I know there are so many educators who are teaching you in Hindi inside Unacademy, but there are now, recently we have launched so many batches like Shine, Spark, and another batch also. So you can basically join in those batches in order to boost your rank in your upcoming JEEs for sure, okay? Now, moving on to the next one. If you want to follow me, you can definitely follow me on Unacademy. This is my username, because we are coming up with so many special classes that's completely for free. So for that, you have to just download the Unacademy app. Go inside over there, search my profile, Yawar Manzoor, and you will get my profile, and open the special class session. Understand? That's completely for free. You can watch any time my special classes. So this is my code. It will ask you for a code over there. So use this code in order to enroll in my special classes. Now, these are the batches which have recently launched. Now, this is the Shine 2.0, which is for the English people. Understand? So if you want to enroll in this batch, you should go for right now. Understand? Because this is completely in English language, and this will start from 15th of September. Understand? So I suggest you to take this branch so that you will not miss, understand, any of the stuff what will be going in this one. So this is for the JEE Mains and Advanced 2022. That's coming up in the upcoming time. Okay, fine. Now, moving on to the next one. If you take this plus subscription for 12 months, you will be getting basically what? For this much of price. Now, if you use my code, you can definitely get the maximum possible discount. Same goes for this 18 months. If you take this subscription for 18 months, you'll be getting it for this much of price, and you can use my code in order to get the maximum possible discount. Now you will have question in your mind, are the EMI options available over here? Definitely yes, you can pay it every single month. You don't have to pay the entire amount at once only. Okay, now the point is this is available for 3 months and 6 months also. You can take this plus subscription for 3 months as well as 6 months also. So you can take it for 24 months also. This is the price for 24 months. And this iconic subscription, you can take it for 12 months, 18 months, 24 months. And by using my code, you can get definitely the maximum possible discount that is possible. Okay, so this is for the 24 months. Now, if you are aiming for JEE 2022, understand there is some big surprise that's coming up for you people, so that then you have to basically wait for that. Now listen to me very carefully. This is a ask a doubt session on Unacademy. Understand, if you have any sort of doubt, this is one of the beautiful features that Unacademy has inside. Understand, so if you have unlimited number of doubts, you can ask and you will get the video solutions, that too in high quality. Understand, you can ask that doubt any damn time. Understand, morning, evening, afternoon, whatever the time is, and you will get the exact solution from that only. So how you can exactly ask this doubt? You have this doubts and solution feature inside Unacademy. Understand, you have to click on that. Over there you have to basically select the picture of that particular doubt that you basically wanted to ask. So crop that one. That image should be basically clear. It should not be blurred, so that our educator would be able to see it very properly. Understand? Now, afterwards, you need to crop that session. Understand? Whatever you want to basically ask to your educator, you need to crop that session. And afterwards, you'll definitely get the solution for that. Okay? Hello. Thank you. Thank you. Thank you. Thanks, means a lot. Okay, so these are basically the do's and don'ts, means what are the rules and protocols that you need to follow exactly when you are supposed to ask the doubt. Understand this? Now, ladies and gentlemen, we'll be talking about this projectile motion. What exactly this projectile motion? Let me just give you the feel. Once we get done with all the stuff, understand, afterwards we need to move on to something that you will love. Okay, previous year, some of the beautiful previous year questions. Okay, I'll be keeping the homework as well today, so you people are supposed to solve that, and do let me know the answer of that question in the comments down below. Okay. Yeah, finally the live class after a long time. Still internet is not working in Kashmir. Okay, the speed is very low. It can go anytime. I don't know about that. Okay, yeah. So this is basically the broadband. Only BSNL broadbands are working over here. That's why my internet is working. Rest, everybody else, like mobile phone internet connectivity, calling connectivity, everything is blocked. Okay. Yeah. Now, no, calling is working right now since yesterday. Okay. Internet else, everything is blocked. Okay. Okay. Let's move on to this one. See, I'll make you understand this projectile motion in very detail. Listen to me very carefully. Listen to me very carefully. Previously, we were talking about the car was moving on a straight road. This is a horizontal motion. This is traveling from this point. This is traveling from this point exactly to this point. Understand? So it started traveling from this point to this point. This was horizontal motion. It was moving horizontally. Fine. We called that rectilinear translation motion, linear motion, whatever it is. Okay, horizontal motion. Now, then we launch this block. We basically throw it in the upward direction and it falls back. We call this as a vertical motion. Understand? This block first in upward direction, then it falls back. So we call this as vertical motion. Understand? Now, we have studied this vertical motion completely in detail. What are the basically expressions over here, how much a displacement, how much time it's going to take to reach the maximum height, everything we have studied this in the previous classes. This also we have studied in kinematics properly. Now, if I ask you the very simple question, that is there some sort of motion which is just the combination of horizontal motion as well as a vertical motion? First of all, let me just tell you what is this projectile motion in simple words. You are, for example, launching something. This is a ball in my hands. Okay, I'm throwing this ball in this like this. Okay, it is basically following this path, some sort of this projectile path, understand? This one, parabolic path. So this is nothing but projectile motion, launching something and it will reach this one. See, this is what we call the horizontal motion, moving in a straight direction, only one dimensional motion. This is the two-dimensional motion. Two dimensions are changing over here. I'll clear everything after some time. Right now, basically, you try to focus on whatever I'm saying. So this is simply the projectile motion. Fine. So this is vertical motion. I'm throwing this one. So in this case, the ball will basically go up, and then will fall back. This is nothing. This is the very simple example of projectile motion. That is what we're gonna be talking about over here. Now listen to me very carefully. Let's basically move into this projectile in very detail, what exactly this is. I'm saying that this projectile motion is nothing but the combination of this horizontal motion and vertical motion. See, what happens in horizontal motion? You'll say, sir, in this horizontal motion, the body travels from one point to another point. That's fine, okay? Initially, it was at this point. Finally, it is at this point. And what happens in this vertical motion? You'll say, sir, we basically throw this ball in upward direction, then it falls back and reaches the original point once again. Started from this point, goes up over there, velocity becomes 0, and it falls back at the same point, original point. Understand? So what happens over here? Ball goes up and then falls back. What happens over here? Ball goes basically from one point to another point. So this, I'm asking you, if we combine this and this, if we combine this horizontal motion and this vertical motion, what will be the resultant over there? So the resultant has to be something. The ball should go up and then and then it should fall back, as well as it should move. It should not basically fall on its original position. So it should be exactly something like this only. Understand? So in this case, this ball is going up. Understand? In this case, the ball is going up and then it is falling back. See, it is going up, this maximum height, it is falling back. And it is not falling back on its basically original position only. Understand? So there is some other point it is reaching. So it is following the rules of horizontal motion. It is following the rules of vertical motion. It is going up as well as then falls back, and it is moving from one point to another point. So this one plus this one. Everybody understood? Come on. Yes, this is simply the case of two-dimensional motion. I'll tell you everything about that. Chill scenes. Till here you understood? Yeah, mark the attendance, everybody. I want you people. Okay, that's great. Fine. Now people say this is also the 2D. Okay, you are saying this is an example of two-dimensional motion. What is that two-dimensional motion? Two-dimensional motion means, see, in this case, is this one-dimensional motion? Definitely yes. Only one of its coordinates are changing. Over here, value of x is something. Over here, it is value of x is 0, value of x is 1, value of x is 2. So x changes, y remains constant. In this case, if I say, for example, over here, x value is, for example, 2. Understand? This keeps on falling. So what is changing over here? Y is 5. When it reaches here, y is 4. When it reaches here, y is how much? 3. So y is changing, x is constant. Only one of its coordinates are changing. Now let's talk about over here. So when you throw the ball from this point to this point, when the ball was exactly going from this point to this point, means it has changed it is moving in x, as well as it has covered some y displacement also. X as well as y. It will have velocity in x direction as well as y direction. So can I say that over here, two of the coordinates are changing, x as well as y. So basically, if it was moving through this only, so it was only changing one of its coordinates. Now, it is going in this path, means it has covered some distance in x, it has covered some distance in y. So means two of its coordinates are changing. So can we say this is an example of two-dimensional motion? Because two of the coordinates are changing, that's why. Now, that's where you were asking. Yeah. Okay. Clear now? Now, fine. I'll give you the feel of this point, that how this is an example. How if I am going too fast, just let me know in the live chat, then I'll decrease my speed, okay? I just need to know in the live chat. If I'm going too fast, then I'll decrease my speed. Now, listen to me guys very carefully. I'm saying that how this is exactly the combination of this horizontal motion and this vertical motion. Let me just give you the feel. See, for example, if we say we are launching this ball, this projectile, you are firing the gunshot, that is also some sort of projectile motion going from this point to this point. Understand? So it will basically go from this point and it will reach this point. Now, I'm asking you, for example, this happens in the dark room. There is this dark room, okay? Now, you are basically switching on the torch. Okay. Arey yaar. Okay. You are basically switching on the torch on this one. So you are basically switching on the torch this one. So there is a screen over here, some sort of screen, wall, whatever it is. Understand? Now, when you switch on this torch and you started basically launching this projectile from this when basically this projectile will move from this point to this point along this path. And if you try to have a look on this screen only, it will appear that basically do this experiment at your home. It will be exactly like this. You will basically feel that on this screen, it will appear like this ball is going up. When it reaches this point, it has reached this point. So when it starts coming down, it will start come down. So on this screen, it will appear like this ball is only doing vertical motion, going up, falling back, going up, falling back. Understand? So that's why I'm saying that this is a combination of vertical motion as well as horizontal motion. Now the second point is you basically draw the light from the upper side and you put the screen over here. When you try to have a look on this screen, it will appear that on this screen the ball will basically move like this. When the ball goes from this point to this point, from this point to this point, and then it falls, basically falls back, and over here it will reach over here. So that's why I was basically saying it is just a combination of what? Horizontal and a vertical motion. Everybody? Come on, I just need to know in the live chat. Everybody understood what I'm trying to say exactly? Okay, that's great. Why not? I don't know. Somebody help this Aditya. Why isn't the PDF downloading? Fine. Now, there are some more examples of projectile motion. What is that? This is the long tower, I would say. Okay, this is a long building. So from this building, we are basically throwing this ball and it will basically fall over here. So this is also an example of projectile motion. Projectile from some height. So initially, the previous one, we were launching that from ground to ground, ground to ground. Understand? That's what we call the angular projectile. This is the projectile from height. We are launching this from a height. So its path will be something like this. This is also an example of projectile motion. Next example is, for example, you launch the same ball from some height and it should be something like this. You launched it at some angle, for example, I would call it theta. And this you throw horizontally, horizontal projectile. You call this as horizontal projectile also. Understand? You're launching this projectile at some height. This is also an example of projectile. Understand? And after some time, in the next lecture, we'll be talking about this projectile. You're launching this at some angle over here. Initially, it was at some angle. Understand? At incident plane. So these are all the examples of projectile motion that we need to basically look after some time. Today, in this lecture, we will be talking about only the projectile motion, which is from ground to ground. We are launching this projectile. We are throwing this ball from one point of the ground and it will fall on the another point of the ground. That we'll be talking about exactly. Okay. Now, in projectile motion, the horizontal motion remains unaffected. Understand? In projectile motion, the horizontal motion remains unaffected. What does it exactly means? That in this projectile motion, we say this is basically the combination of horizontal motion as well as vertical motion. Understand? So if this is performing, if this projectile motion, if this is the projectile motion, its horizontal motion will not affect its vertical motion and its vertical motion will not affect its horizontal motion. These are the golden points, okay? You will find it nowhere. Nobody is going to tell you. The people who actually teach you projectile motion, they directly start from this is the height of the projectile, this is this much, and then start solving the problems. So these are the golden points. That's why I'm saying comparing the concepts with the real life situations, that gives you the exact feel of physics. I just need to know in the live chat. If everybody is understanding every damn thing. If not, then do let me know. Come on. All of you. If you are getting any sort of confusion, like for example, if I'm going too fast, I just need to know. Then I'll slow down my speed. Or is it fine for you? Okay, that's great. Okay. Meenakshi is saying slow. Okay. Fine, fine. Okay, okay. Now, so let us basically discuss this first point, that is, in projectile motion, the horizontal motion remains unaffected. What does that mean? That means its vertical motion will not affect its horizontal motion. How exactly? For example, this is a plane, okay? This plane is moving in the forward direction. I would say, for example, 10 meters per second. I have basically discussed this example previously when we were talking about the relative motion. Okay, so I am saying that this plane is moving in the horizon, like this, in horizontal direction with 10 meters per second. So this plane exactly, this plane is moving in the horizontal direction. Okay, it basically released a package. Will this package will fall directly in the vertical motion, or it will fall directly, it will fall something like this? Obviously something like this, because the velocity this plane is having, this will be having the same velocity because both are together initially. Understand? So it basically released the package from here. Understand? So this package will be also having the 10 meters per second in the forward direction, but this package will also be having some velocity in the downward direction. Understand? Because gravity is attracting this, so that's why it is falling down. Okay, so I would say, for example, whatever it is, that is 5 meters per second, I would say. So this is falling down as well as moving forward. Now after some time, the plane reached this point. Okay, so this is basically following the path something like this. It is falling something like this. Understand? So when basically this pilot, it checked that the package is exactly on his vertical line at some height. Understand? Below the height of this plane, exactly it was over here. So can I say that if this package is falling down but it is moving with the same velocity in forward direction, see, clearly it is following the projectile path. I told you this is something like this. Projectile launched at some height, understand? So this is something like that. So this is basically the height at some height. So it will basically fall something like this. It is having some horizontal velocity initially, that is 10 meters per second. Now if it is falling like this, I can definitely say that like that, it is exactly over here, the plane is exactly over here. So I can definitely say it like that. This plane is having 10 meters per second. This will be also having 10 meters per second. So this ball, this package is going down with a velocity of 5 meters per second, means this vertical motion is not affecting its horizontal motion. It will still keep on moving 10 meters per second horizontal velocity until it reaches the ground. When it will hit the ground, at that point of time, it will also have 10 meters per second also in the horizontal direction. So that's why I'm saying in projectile motion, the horizontal motion remains unaffected over here. Understand? Or this vertical motion will not affect its horizontal motion. And you will have questions in your mind. Why is it like that? Because there is no force in horizontal motion. It's a vertical motion will be basically affected by the gravity. Understand? So if we talk about its horizontal motion, it will remain unchanged because there is no force. If we talk about the air resistance, we neglect that air resistance. So no force. If there is no force, there is no acceleration. So if there is no acceleration, velocity will remain same. Velocity will remain constant. When velocity changes, acceleration comes, means there is some sort of force. Everybody understanding this one? Or are you getting any sort of confusion? Come on, do let me know. Okay, so this is the scene over here. In projectile motion, the horizontal motion remains unaffected. Understand? So after some time, I'll tell you the horizontal velocity will remain unaffected because there is no velocity, because there is no force in x direction. Understand? And if we talk about its y direction, gravity is pulling it in the downward direction. Now its horizontal motion also does not affect its vertical motion. Okay, its horizontal motion will not affect its vertical motion. What is that? See, if this plane is moving in the forward direction, so this package will be having the same velocity, I would say 10 meters per second. This will also be having 10 meters per second. Sorry, this plane is exactly at rest. This was the another example. Okay, this is the plane I am talking about. So if I say this is moving with 10 meters per second in the forward direction, this will be also having, that is 10 meters per second in the forward direction. So this will be also having 10 meters per second over here. This is the same plane moving in forward direction. This will be having 10 meters per second as well as it is falling back. Understand? If we try to have a look on its vertical motion only, so vertically it is falling only in downward direction. Okay, I know this is falling something like this. That's okay. But if we talk about its vertical motion only, forget about the horizontal motion. We know that remains unaffected. But if we talk about its vertical motion only, so it will fall directly down. So if there is another plane over here, which is exactly at rest, this is first plane, this is another plane. So this was in motion. When this released the package, at the same time, this another plane at rest, it also released the package. So if we try to observe the vertical motion of this package and this package, it will be exactly same. It will be exactly same. Understand? This is moving forward, but I am asking you to analyze its vertical motion only. Forget about its horizontal motion. It's vertical motion only. So it will fall exactly like this plane, like this plane. Understand? You getting me? If this initially released this from rest, means vertically. Understand? So it is basically no velocity in y direction initially, so it will be exactly like this. How many of you people understood these 2 points? Come on, I just need to know in the live chat. Do write CC, crystal clear. Come on, all of you. In the live chat, I just need to know. Come on. Okay, that's great. Because these are some of the golden points. That's why I'm saying, okay. So what is the first point? In projectile motion, the horizontal motion remains unaffected. The second point is horizontal motion also doesn't affect its vertical motion. Okay. It's an example. It's a motion in a plane. Understand? Motion in a plane. What's plane? Plane is this board. Understand? 2D plane. Understand? We say this is only one dimensional, or over here only one of the dimensions are changing. If we say this is a plane. Understand? Not 3D, 2D. It's a two-dimensional motion. Projectile given an angular, this one. Now let's talk about some of the beautiful points. Okay, fine. Listen to me very carefully now. If we, for example, launch this projectile, I'm throwing this ball from this point, and it is basically reaching this point, okay? So this is the scene happening over here. Let me just show you. It is something like this. I'm just making the coordinate system as well over here. Fine. Everybody. Okay, great. Now, if I say, for example, so I'm launching this projectile from this point to this point. With what velocity I'm launching it? I'm saying, for example, I'm launching it with a velocity of, for example, u. Okay, initial velocity, I'm giving it, for example, I'll call that initial velocity u. Okay, at what angle? With this horizontal, I would say this is at horizontal theta. So if this is its initial velocity u, at some angle, can I say this velocity will have two components? One will be along this horizontal component, another will be its vertical component, because this is motion in 2D. Understand? That's why. So this will have two components. So first will be this one. Can I say this will be nothing but u cos of theta, initial velocity cos of theta, and this of its component will be nothing but that is u sine of theta exactly. Okay, these are the two components of this one. 100% over here. Now we need to basically analyze its horizontal motion as well as its vertical motion. What happens? What are the scenes that happen in its horizontal motion as well as vertical motion? Because it is doing the horizontal motion as well as vertical motion, already discussed. It will have horizontal displacement also. This horizontal displacement also, vertical displacement also, vertical displacement also. Fine. Now, so have a look on this question. I just want to basically make you understand this exactly what happens over here. Okay, listen to me very carefully now. Yeah. Now see. So this is what we call the projectile given an angular projection. Projectile given an angular projection. This is not the horizontal projectile. You are throwing it from some building. Okay, it will fall something like this. No, it is at some angular position initially. Fine. Projection, not position. If we talk about its horizontal motion, first let's divide this motion horizontally. We'll talk about its velocity, we'll talk about its displacement, horizontal velocity, because this is the combination of horizontal motion and vertical motion. Let's talk about its velocity initially. Can you tell me what is the velocity in x direction initially? You'll say, sir, that is nothing but u cos of theta, And this is in x direction, so can I say this is nothing but ux? This is nothing but in y direction, can I say this is nothing but uy? So definitely. So can I say this nothing but ux, initial velocity in x direction, is nothing but ux cos of theta. What happens with the velocity in y direction? You'll say, sir, that is nothing but uy is equal to uy, sorry, this is u cos of theta only. U cos of theta only. So this is nothing but that is u sine of theta. Can I say it like that? 100%. Now the second thing is over here. You will say, sir, what happens with the acceleration in this case? So we say in this case, what is the acceleration in y direction? In case of vertical motion, I have told you motion under gravity. This is motion under gravity. Can I say in y direction only there is this acceleration due to gravity, understand, downwards, and we take that acceleration due to gravity as negative, previously discussed in detail. Okay, so I say in y direction, ay is nothing but over here, that is g, and we take that always negative, understand, towards the center of the earth, towards this downside, okay, downwards. Fine. Now the second point over here is, in this case, can you tell me what is the acceleration in x direction? Sir, there is no acceleration in x direction. Why? Because there is no force in x direction, so acceleration will be zero. When there is force, there is acceleration. See, if there is a body moving with constant velocity, you apply some sort of force on that one, understand? Yeah, you apply some sort of force on that one. So afterwards, what happens with that force? Velocity change, acceleration comes, as there is no force in x direction, so there is no acceleration in x direction. But in y direction, there is gravity. That's why we say over here acceleration due to gravity. Fine, clear? Now you tell me one thing. What is, if I ask you to tell me the final velocity at some point, what is the velocity at some point? Understand? Can you tell me what is the velocity at some point after some time? What happens with the velocity? Now see, if there is no force in x direction, can I say after some time final velocity at any point? So that will be equal to initial velocity only. It will remain unchanged. Understand? If I talk about over here, this velocity will be exactly equal to this velocity, u cos of theta only, because there is no force in x direction, so velocity will not change. If force comes, velocity changes. So over here, from this point to this point, horizontal velocity remains constant, unaffected. So previously discussed also, horizontal motion remains unaffected. So it will be nothing but u cos of theta only. We can prove it as well. How we can prove it? Use this equation. Can we use this equation over here? Acceleration is 0. We can use this one. We use these equations. V is equal to u plus at. S is equal to ut plus half of at square. V square minus u square is equal to as. We use these equations when acceleration is constant over here. Over here it is 0. We can use this one. So Vx is nothing but ux plus at. Axt. Ax. Understand? We are using this one where, for example, at some point, I am asking you at this point, what is the final velocity in x direction? In x direction, understand? You'll say, sir, it is very simple. That is Vx initially is nothing but ux plus acceleration in x direction, that is 0. So 0 into t. So Vx is nothing but that is ux only. Vx is ux. This is the proof. Now what happens with the velocity in y direction? Let's check. There is force. So velocity will basically change over here. So let's see. So we'll say Vy, understand? At this point, if I ask you how much is this v component, that is Vy component. This is Vx component. This is v. Understand? This is initial velocity, x component, y component. Any sort of confusion? Yeah, exactly. Fine. So can I say over here, this will be Vy is equal to uy minus gt. Why gt? Okay, let's just write that only. Vy minus a plus ay into t. Now I am using this equation in y direction. Understand? In vertical motion. So can I say over here, it will be nothing but Vy is nothing but that is uy. What is uy? U sine of theta. U sine of theta. And instead of this acceleration ay, we take as minus g into t. Means what is happening with the acceleration? Y direction acceleration. That is nothing but that is decreasing. This is u sine of theta initial minus something, initial minus gt. So means that vertical velocity decreases. So from this point to this point, vertical velocity decreases. That's why over here the body stops. Understand? It will not go more up. It will now start falling down. Understand? So why? Because gravity is attracting this one. So at this point, we say at this point, y component of the velocity becomes 0. So clearly I can say it over here. Clearly I can say it over here. This y component decreases from this point to this point exactly. And what happens with the x component? It remains a constant. That is ux only. Everybody understanding? That's great. Fine. Okay. Somebody please tell him, Dheeraj, when is the next prodigy test? Okay. That's great. It has to be crystal clear only. Understand? So from this point to this point, we say velocity in x direction, x velocity remains constant, and a y velocity from this point to this point becomes 0. Understand? You getting me what I'm trying to say? Okay, it's gonna be okay. Fine. So this happens over here. And what else? And we say, for example, this horizontal, in this horizontal motion, we call it that horizontal displacement, okay? Or we say it nothing but x. How much you have displaced from this point to this point. Understand? Horizontal displacement. And we call this as vertical displacement as y, vertical displacement. You can call it anything, okay? So that is vertical displacement. How high you can basically exactly go in this case, that is the vertical displacement. That's gonna, over here, how much is the vertical displacement? Horizontal displacement. Fine. Now, so these are the points you just need to basically focus on. Y decreases. Explained everything. Fx. Fine. Now, ladies and gentlemen, boys and girls, now we have something. Okay. Okay. Chris is the genius you are with the second ID. Okay. I get it. He is not new. He is 18 years old. Okay. Bhai, main to kal hi paida hua. Okay, so for example, if I say we're launching this projectile from here and it will somewhere over here fall, understand, at this point. So this is the angular projectile. If I ask you in this case, how much time it's gonna take from this point to this point, can you calculate that time? That's what we call the time of flight. For how much time it will remain in air, time of flight. For how much time, what will be the flight time? For how much time it will be in the air? Or how much time it's gonna take to reach from this point to this point exactly, that we need to calculate. Now, after some time, they'll ask us to find how high it's gonna go. What will be the maximum height? This h max that we need to calculate. And we'll say how far it's gonna go from this point to this point. There is some projectile that will go from this point to this point only. Some projectile will go this point only. So these are the ranges. This is what we call the range. Okay, then we need to find basically equation of this trajectory. Understand what is the equation of this curve, that will find everything. Okay, let's find first the time of flight. Can you guys tell me what is the time of flight? Everybody in the live chat. So from this point to this point, how much time? If we are launching it with the velocity u. अरे हाँ वही 17. 2u sine theta by g. Fine. Okay, so I'm saying that, for example, I'm launching this projectile with a velocity, initial velocity, that is u. U is the initial velocity. At what angle? I would say angle theta. This is x and this is over here y. Fine. Can you tell me what are the two components of this initial velocity? You'll say, sir, it is very easy. That is u cos of theta, and from this it will be nothing but u sine of theta. Can I say this is nothing but uy and this is nothing but ux? Fine. Now, if I ask you to tell me the time from this point to this point, what is that? I will say that is time of ascent. Understand? So from this point to this point, you find the another time, that is a time of descent. See, exactly, if we get this time from this point to this point, how much time it's gonna reach the maximum height? Same time it will take from this point to this point in falling. Understand? We have discussed this in vertical motion as well. This time of ascent is equal to the time of descent. So we'll get this time plus this time and we'll get the total time. That's all. That's what we are supposed to find. Let's find this time A. Understand? From this point to this point. So which equation we can use over here? Tell me. Can we use this equation? V is equal to U plus AT. So we'll say simply that is in Y direction from this point to this point. Why in Y direction? It's simple, yaar. Because it is saying us that how much time it's gonna take, in for how much time it will remain in air. Understand? For how much time it will remain in time of flight. Understand? So Vy is equal to Uy plus AY into T. Understand? And I'll just call it that TA. Fine. From this point to this point, we are using this equation. Understand? Clear? And acceleration is constant G. So we can definitely use this equation. We can use these equations only under certain conditions. That acceleration has to be constant. So can I say this? Vy at this point, velocity in Y direction is a 0. Vy is a 0. Understand? Upward, then only it will start falling back. It will start falling back. So this becomes 0. Initial velocity is nothing but in Y direction. That is U sine of theta. U sine of theta. And acceleration is nothing but Ay is nothing but that is minus G, and this is a TA exactly. So can I just write this? TA will be nothing but, take it over there. So it will be nothing but U sine of theta by G. So this is the time of ascent. Now if I ask you to tell me the time of descent, you'll say, sir, this TA is equal to TB only. Now in that case, if this is equal to TA is equal to TB, I'll say total time is this time plus this time. So T is equal to this TA plus this TB. So can I just write this T is equal to this TA is what? U sine theta by G. U sine of theta by G plus this TB is U sine of theta by G. Can I just write this T is nothing but 2U sine of theta by G. Total time. Understood everything, everybody? It's very simple. Okay. Now there is another method also in order to get this time. What is that? That is nothing but, okay, I'll tell you over here. Okay, I'll just tell you that over here. I'll tell you 3 methods. Okay. In vertical motion, when we were basically throwing the ball in upward direction and then it falls back, over there we have discussed how much was the time that came out to be. T is equal to 2U by G, total time. In going up, in coming back. In going up, it was taking U by G. In falling back, it was taking U by G. Total time was 2U by G. So over here, instead of that U, we are taking what? Y component of that velocity only. So can I just write, if that is the case, T is equal to U by G. In case of vertical motion, ball throwing up and it falls back, how much time it is taking? 2U by G. So over here, instead of this 2, we are taking that is Uy by G. So T is nothing but how much is Uy? That is U sine of theta by G. Next method. Let's go for the third method. S is equal to UT plus half of AT square. Understand? Idhar. Arey yaar. Plus half of AT square. You tell me one thing. Can you use this? S is equal to UT plus half of AT square in Y direction, in Y direction, in Y direction. So what is the displacement in Y direction? See, body leaves from this point and falls back on this line only. So how much is the Y displacement? Displacement is Y, 0. It has a displacement in X, but now when it reaches this point, displacement in Y and this is 0. So I would say this is 0. Initial velocity in Y direction, that is U sine of theta. Time is that we are supposed to find. This is total time right now. From this point to this point exactly. That is nothing but this T. And instead of this plus, I'll just write minus because A is minus G. Minus 1 by 2 G, this T square. This square and this T will cancel. So this will be nothing but G by 2 into T is U sine of theta. This T will be nothing but U sine of theta, 2U sine theta by G, where this T is total time. Come on. Understood this third method? Am I going too fast? Sometimes I go because I have to cover a lot in just in a particular duration. That's why. Is this crystal clear? Come on. Okay. Okay. It's gonna be okay. Okay, let's go for the next one. What's the time? 45. Okay. You need to find the maximum height now. Okay. So means when this ball is launched from this point, so how high it can go exactly, that is this H max that we need to exactly find out over here. How can you find this H max? Use this equation directly, or you can use maximum height. Means we need to basically use the equation from this point to this point, because then only we'll get this maximum height. So which equation? So this equation, v square v square minus u square is equal to ay into sy. Understand? Displacement in y direction, acceleration in y, initial velocity in y, final velocity in y. Okay, this is the exact equation. Okay, fine. Now what is basically the final velocity at this top? Because we are using the equation till here. Final velocity over here is vy is 0. So can I just write this is nothing but 0 square minus this uy square. What is the initial velocity in y direction? That is u sine of theta. That is this u square sine square of theta is equal to nothing but 2. Acceleration, that is minus g. So I'll just write minus over here, minus g. Displacement in y direction, that is h, that we are supposed to calculate how high it can exactly go. In this case, this minus will cancel. So can I just write directly h will be nothing but u square sine square of this theta by this 2g. This is the expression for maximum height, how high it can exactly go. Now, if you try to have a look on the expression of what? Vertical motion expression. Understand? Vertical motion, how? If we are, for example, throwing the ball in upward direction, how high it can go, and in that case, how we used to calculate that? We were simply saying that is, sir, h is equal to u square by 2g. Now over here, instead of this u is what? uy. Can I just write it is nothing but uy square by 2g. So h is nothing but, that is what? This is vertical motion formula. So over here, can I just write v, instead of this is nothing but u square sine square of theta by 2g. Fine. Or there is another method also that you can use. I'll show you over here. S is equal to ut plus half of at square. S is equal to ut plus half of at square. Fine. So instead of this s, you will basically take what? This h over here, which h. Instead of this u, what is the velocity in y direction? That is u sine of theta. U sine of theta. What is the time in going from this point to this point to this point? Time of ascent only. That is u sine theta by g. So put it over here. U sine of theta by g. And then it will be minus, I'll just write over here, minus 1 by 2 acceleration in y direction, that is g, and this u square sine square of this theta by g. Exactly. I'll just erase this one. Okay. So when you basically solve this is u square sine square of theta by g. Understand? U square sine square of theta by g. Over here, this is g square, because this is time square. U square sine square of theta by g square. This square and this g will exactly cancel. Now see, u square sine square of theta by g minus 1 by 2 u square sine square of theta by g means 1 minus half. What you will get? Exactly half only. So that will be h is nothing but, that is u square sine square of theta by 2g only. 3 methods I am showing you. Okay, let's move on to the range. What is the range exactly? How far it can exactly grow from this point to this point. So we represent this range by x, r, whatever it is. So let's go with this r. Understand? What is the velocity in x direction? What is the horizontal velocity? That is, see, in this case, we're using this equation from this point to this point in horizontal direction, because we need to find the range, this horizontal range. So velocity in x direction, ux is u cos of theta. So put it over here. That is u cos of theta multiplied by this t, and 1 by 2 axt square. acceleration in x direction 0, so this will become 0 only, so it is this only. So can you basically solve this? R is equal to u cos of theta. Instead of this t, how much time it is taking from this point to this point to this point? That is 2u sine theta by g. So that is 2u sine of theta by g only. Okay, so further we can write it this, r is nothing but, this r is nothing but, that is this u square 2 sine theta cos of theta by this g. So can I just write r is equal to u square 2 sine theta cos theta sine of 2 theta, I guess, by g. So this is basically the range. Okay, you got it, man. Fine. Now, when the range is maximum, can you guys tell me when the range is maximum? Yeah, it has to be crystal clear. Can you guys tell me when the range is maximum exactly? When can be the range maximum? Come on, I just need to know. When can be the range maximum exactly? How is it 45? How can you explain me from this one? I'll tell you two methods, okay? Two methods, okay? Means that, for example, if we are launching this projectile from this point to this point, okay? What can be the maximum range? R maximum. Now, the point over here is, see, this is the range, formula for range. So, if you want this range to be maximum, you will say, sir, I'll launch it with the large velocity. Okay, I'm saying fine. You will launch it with the large velocity, range will be maximum. So means this velocity depends upon you. How much you can go, you'll say, I'll give it maximum. Now, this g is constant. Over here, that is theta. This sine theta means this range ultimately depends upon this sine theta. Understand? See, you completely depends upon you. How much velocity you'll give? You'll say, I'll give maximum. I'll say, okay, you give maximum. Next, on what this range exactly depends. So this range depends upon this sine theta. Sine theta depends upon theta. So you need to basically launch this. You need to basically launch this projectile at some angle, At that angle, the range will come out to be the maximum. Why? Because the range depends upon theta only. What angle? You'll say, sir, I'll launch it at 30 degree, it can be maximum. I don't know. At 60 degree, it can be maximum. I don't know. At 45 degree, it can be maximum. I don't know. Let's check. Understand? At what angle the range can be maximum? You'll say, sir, why are you saying at what angle? Because the range depends upon angle only. At what angle? You'll say, sir, velocity also. Velocity, okay, but that depends upon you also. Now you are saying, I'm giving the maximum velocity. After that maximum velocity, the angle has to be something on which range is maximum. Understand? Yeah. See. The main point is, you will say, sir, it depends upon the velocity also. I'm saying, okay, but velocity depends upon you. You'll say, I'm giving, sir, maximum velocity. Okay. After that, does it again depends upon something? That is theta. If you give the maximum velocity, theta is not the correct angle. It will not have the correct range. So that's what I'm trying to say over here. So range depends upon this sine theta over here, sine 2 theta over here. Understand? So, but sine of this theta depends upon what? Theta. Theta increases, sine theta increases. Okay. Now, over here, can I say what is the maximum value of sine theta? That is nothing but 1. So over here, I can say this sine of 2 theta, its maximum value is 1. Understand? So in that case, can I say when is the sine of theta, when is the value of 1, when is the sine theta's value 1, when sine theta is, when it is sine 90. Understand? Because that is 1. So can I just write this sine of 2 theta is nothing but sine of 90 exactly, sine of 90 exactly. So this 2 theta will be exactly 90. So theta will be nothing but 45 degrees. So means this angle has to be 45 degrees. Then only you will get this maximum. At theta is equal to 45 degrees, the range will be maximum. How many of you people understood this? Come on. What I exactly did over here, saying a range depends upon sine theta. Sine theta itself depends upon theta. If sine theta depends upon theta, what is the maximum value? Because we need the maximum value of this sine theta. then this quantity will be maximum, range will be maximum. Range directly depends upon this one, okay? So sin theta maximum, range maximum. So what is the maximum value of sin theta? You'll say, sir, that is 1, okay? So sine of 2 theta is 1. Sine of 2 theta is sine of, when is the value of sin theta as 1? That is sin 90. So sin 90, 2 theta, 90 theta, 45. Okay. Another method. This is a good method, okay? You love this, okay? You will love this. Yeah. Okay. Okay, let's find that. Somebody is saying that u square by g. So it will be, so at theta is equal to 45, range is maximum. So how much is that maximum range? Can we find it over here? So u square, if we are launching with a velocity u over here, understand? So u square sine of 2 into this theta is what? That is 45, pi by 4, okay? So that will be pi by 4 and this will be nothing but a g. So this is 2. So can I just write this is sine of pi by 2, that is sine 90. So this will become 1. So range maximum will be nothing but u square by g. खुश भाई बस यही पूछ रहा था. Okay. Another method. This method will give you the feel of physics. Now see, golden method. What is that? See, I have told you previously, if there is a quantity that is y, this is x. Y is changing with x. If the graph is, for example, coming out to be something like this. If the graph is coming out to be something like this, okay? Like that, this, okay? If I ask you over here, you tell me one thing. At this point, what is the value of slope? You'll say, sir, that is dy by dx. Understand? Slope is what? 0 over here, because this tangent is making 0 degrees with this one. Theta 0, tan theta 0, slope 0 means that at this point, dy by dx is 0. At this point, dy by dx is exactly 0 because it is parallel to this one, this tangent. Understand? Now, can we say that this is minimum point, this is maximum point? Clearly, this is minimum maxima. So, on maxima or minima, we know what? That dy by dx is 0. Understand? Dy by dx is 0. Rate of change with respect to y is 0 because we proved it. Minima, maxima. Fine. Now, if you want to find exactly at this value of x, dy by dx is coming out to be minimum or maximum at this point, dy by dx is coming out to be the 0. Okay. Now, if you want to find exactly the maxima and minima, you check for double differentiation. That is d2y by dx2 is coming out to, if it coming out to be negative, then it is nothing but a maxima. If it is coming out to be positive, then it is minima. Okay, we have discussed this clearly. Now over here, this is the expression, that is r is equal to u square sine of 2 theta by g. So we say r is equal to u square sine of 2 theta by g. So r depends upon theta. Understand? So theta changes, r changes. R depends upon clearly theta. Now in this case, we need to find, listen to me very carefully, we need to find that value of theta. At that value of theta, r has to be maximum. Like, what is that value? That is 45. We know at this value of theta, range is coming out to be the maximum u square by g. Now same with this method. Like here, at this value of x, it is value of this y is coming out to be minimum. At this value of x, value of y is coming out to be the maximum. Understand? So at this value of x only, dy by dx is 0. So can I say that? Can I say that at that value of theta, r will be maximum and dr by d theta will be 0? Kitno ko chamka? How many of you people are getting this, whatever I am trying to say? Come on. In the live chat, I just need to know. You getting me what I'm trying to say? See, if you want to find basically the maximum, simply you just do one thing, that is dr by d theta. Understand? Because r is changing with theta. You find at what value this dr by d theta is coming out to be 0. At that value of theta, range will be maximum or minimum. Understand? Okay. Now, go for the differentiation of this one. Make it equal to 0. Find the value of that theta. Okay. So, we have to differentiate this one. So, this dr by this d theta, it will come out to be nothing but what? Differentiation of this one, u square by g, we take it as constants, take it out, sine of 2 theta, that is nothing but cos of 2 theta, and this theta, that is nothing but 2. Understand? So what is the differentiation of sine 2 theta? That is cos 2 theta. And this internal differentiation of this one, chain rule, that is for this 2 theta with respect to theta, d theta, it will be 2 only. Okay, so this is the differentiation of this one. Can we put it equal to 0? 100%, because we need to find the value of theta. So over here, so this u square by g and this 2 cannot be equal to 0 because these are constants. So cos of 2 theta is equal to 0. Understand? When is the cos of 2 theta 0? Cos 90. Cos 90 is 0. So can I just write cos 90 over here? So cos of 2 theta is equal to cos of 90. Okay. So 2 theta is equal to pi by 2. So theta is exactly, that is pi by 4, that is 45 degrees. Fine. Now you will say, sir, at this 45 degrees range is maximum, because at this 45 degrees, this dr by d theta is coming out to be 0. If you put it over here, you'll get that. Okay. So this dr by d theta is coming out to be 0. This dr by d theta is coming out to be 0. You getting me? You will say, sir, how? At this one, see, pi by 4, put it over here, pi by 4, that 2 and this 2 will cancel. Cos pi by 2, cos 90, that is 0. 0 multiply that, this, it will come out to be 0. So means at this point, theta is equal to 45 degrees. At this value of x, dr by d theta is coming out to be 0. So means at this point, either it is maxima or it is minima. So at theta is equal to 45 degrees, either it is maxima or it is minima. Now how to find exactly minima or maxima? Double differentiation. So you go for d2r by d theta 2. D theta 2. If that came out to be negative, then only it is maxima. So go for double differentiation of this one. So we need to differentiate this. So it is nothing but 2u square by g. And see, this is 2u square by g. Differentiation of this cos of 2 theta, sine of 2 theta, minus sine of 2 theta, minus sine of 2 theta into differentiation of this one, that is 2. Okay. So it will go out. So this will be 4u square by g, and this minus sine of 2 theta is coming out to be negative. If this is d2r by d2 theta is coming out to be negative, we say it is a maxima. Understand? So at theta is equal to 45 degrees, r is maximum. This is one of the beautiful methods. Okay, it needs the brain to understand. Fine. Everything is clear to everybody. Now same range for two different projectiles. If we basically launch two projectiles at two different ranges, at two different angles, the range will come out to be same. You'll say, sir, at what? If we are launching this projectile at an angle of 30, for example, 30 degrees, okay? If we are launching this projectile at an angle of 60 degrees, so range is, for example, coming out to be 50 meters over here. In this case, velocity is same u, velocity is same u. In this case, range will come out to be this 50 meters only. 50 meter on two different range, same range for two different angles. Range is same for two different angles. It is something like this. You are launching this projectile, something like this. This is at theta is equal to 30 degree. Okay. So it is basically something like this. Okay, yeah. So for this, you are launching this at angle, for example, I would say 60 degrees. This is 60 and this is only 30 degrees. For 30 and 60, range is coming out to be the same. It is something like that. Let me show you the proof. Let me show you the proof. Okay. For two different angles, the range is coming out to be the same. See, we say if angle is theta, so range will be how much? If angle is theta, we say range is how much? R is equal to u square sine of 2 theta by g. Okay. Now, if we say angle is what? 90 minus theta. Understand? 90 minus theta at this angle. So how much range will be? You will say R is equal to u square sine of 2 into 90 minus theta, exactly 180 minus this. So, and it will be upon g. So this again, sine of this thing again comes out to be the sine of 2 theta. R is sine of u square sine of 2 theta by g only. So that's why I'm saying at theta and 90 minus theta, range will be same. At theta and 90 minus theta, range will be same. You will say, sir, how prove? See, if theta is, for example, 30 degrees, now 90 minus theta is how much? 90 minus 30 is what? 60 degrees. So at theta is equal to 30 and 60, range is same. Understand? If theta is equal to 20 degrees, we say 90 minus 20, that is 70. At 70 degrees, the range is same. Okay? For two different angles. You can check it from the book itself. So there is a question. Solve this question and do let me know the answer of this question. Find the velocity of a projectile at any point. Okay, let me just show you. If I say you are launching this projectile from this point to this point, this is the y and this is x. Okay, initially you are launching at velocity with you at an angle theta. Fine. You tell me velocity at this point exactly, at any point. What will be the velocity at this point exactly? Come on, I just need to know in the live chat. All of you, I'm waiting for your answers. How much it would be? Chris H. Yua. The Yua. Which, what was that name exactly? I just need to know the answer of this question. See, if you want to find the velocity at this point, you'll say, sir, it is very easy. It is not that difficult. Okay, fine. So, if you say velocity at this point is initial velocity v, I would say at this point velocity is, over here it is u, over here it is v. So this v will have two components, which if I say, for example, this is making the sign of, for example, theta, theta dash, whatever it is. So this will be nothing but vx and this will be nothing but vy. Can I say it like that? This vx, vy, v sine of, v cos of theta, v sine of theta. Fine. Now if you want to find the velocity at this point, so that will be what? A root of this component plus this component. If you get this component, you'll find that. If you get this component, you'll find that. So that is how much? Vx square plus vy square. Can you tell me this one? See, this velocity is basically root of this square plus this square. Understand? Now, if you got this, if you will get this one, you will get this one, put it over here, you'll get the velocity at this point. How you can exactly get this? Let me just show you. See, this is velocity u. This will have two components. This is u cos of theta. That is ux. This is nothing but u sine of theta, that is nothing but uy. Fine. You tell me one thing. If I use the equation from this point to this point in y direction, so what will I use? You will simply say, sir, that is nothing but vy is equal uy plus ay into t. Fine. I know the initial velocity, u cos of theta. I need to find the final velocity. If I get this vx, I'll put it over here. If I get this vy, I'll put it over here. I'm done. So I need to find this vy. So this vy is nothing but, what is the value of this uy? You will say, sir, this is nothing but u sine of theta. Fine. And this will be minus acceleration in y direction. You'll say, sir, this is nothing but g and this is nothing but t. How much time it's taking from this point to this point? That is t. Fine. So you got the uy. Let's find basically ux. So at this point, this ux, you will say, sir, this vx is equal to nothing but ux. Why it is equal to ux? Because acceleration in x direction remains same. Velocity in x direction remains same. Understand? No acceleration in x direction. So it is nothing but u cos of theta only. So you got ux, uy, put it over here, you get the answer. So u is equal to nothing but, this is a very beautiful question, okay? So that this vx square, how much is that? Vx is nothing but u square cos square of theta plus this. What is this vy? That is nothing but u sine of theta minus gt, its whole square exactly. So can I just write it something like this? It will be u square cos square of theta. It will be plus a minus b whole square. That is a square u square sine square of theta minus a plus b. That is g square t square a square plus b square minus 2ab minus 2. What is a? U sine of theta. What is b? That is g into t. I'll just write it over here. G into t. Fine. Cos square theta plus sine square theta. Between these two, take these two common. It will be u square only. Sine square theta plus cos square theta is 1. So v will be nothing but, it will be only u square now, because this and this will be 0. So we took this u square as common. So it will be nothing but plus this g square t square minus 2u sine of theta into g of t. Understood? Come on. Yeah. You got this one? Chalo, equation of trajectory. Afterwards, we have the previous year questions. Yeah. Okay. We have this equation of trajectory. Understand? So what is this equation of trajectory exactly? Let me just tell you. What is the time? 7:10 already. So I'm launching this projectile from this point to this point. Fine. So if I am launching this projectile from this point to this point exactly, I need to find what is the equation of this curve. See, if I say this is the curve, this is y versus x. Understand? If I say this is the curve over here, what is the equation of this curve? You will say, sir, it is very simple. That is y is equal to x. Means at x is equal to 1, y is equal to 1, x is equal to, y is equal to. Sir, what is the equation of this curve? You will say, sir, it is nothing but y is equal to x square. Understand? So this is the equation for this curve. This is the equation for this curve. Sir, what is the equation for this curve? Let's talk about that. Let's talk about that. Exactly. Let's find the equation over here. So how can we find? See, we need to find what are we exactly finding over here in this case? Y is equal to x. The equation of this curve is y is equal to x. Means with what rate y is changing with x? At x is equal to 1, y is equal to 1, x is equal to 2, y is equal to 2, x is equal to 3, y is equal to 3. Understand? With what rate y is changing with x? This is the equation over here. Same. With what rate y is changing with x? We need to find that. So for that, we need to find the value of x. We need to find the value of y. We'll basically mix both of those, and we'll get the answer. Understand, everybody? Yeah. Happy Teacher's Day. Thanks, man. Okay, now listen to me very carefully. Listen to me very carefully. Now see, if I'm saying, for example, from this point to this point, I'm launching this projectile with a velocity, for example, that same u, okay? Fine, at an angle of theta. Can you tell me, if we use the velocity, if we use the equation in x direction from this point to this point, understand? What is that? That is x is equal to, s is equal to ut plus half of at square. Because we need to find the value of this x. We'll find the value of this y. Mix both of these. Afterwards, we'll get the equation of y versus x. We'll get to know that. So first find this x. So s is equal to, use this. S is equal to ut plus 1 by 2 at square. So over here, x is equal to ut. See, this is the velocity in x direction, that is u cos of theta. Can I say this is the velocity in y direction, that is u sine of theta. X is equal to ut, means uxt. See, uxt. In x direction we are using. So instead of this s, I'm writing x. Understand? So x is equal to uxt, that is u cos of theta, velocity in x direction, multiplied by t. How much time it's taking from this point to this point? That is this t. Fine. So we got this one. Y plus 1 by 2 at square. Acceleration in x direction is 0. So this term will be 0. So we will only get this one. Now use the velocity equation in y direction. Over here I'm just writing. So y, same. Y is equal to uyt plus 1 by 2 ayt square. So y is nothing but, in this case, how much? Velocity in y direction. You tell me one thing, initial velocity in y direction, u sine of theta. Can I just write it exactly like that? U sine of theta multiplied by this t minus 1 by 2 a by t. Acceleration in y direction, that is g. And what is this t? T, how much time? That is a t square only. Fine. Now, you got the value of y in terms of t, but we don't need the value of y in terms of t. We need to check value of this y, with what rate y is changing with x. Understand? So value of y in terms of x only. So can we put the value of x? Can we eliminate this t from here? So we need to basically take this t is nothing but this x upon this u cos of theta. Now put this over here. We'll eliminate this t. We'll get the value of y in terms of x. How many of you are understanding this one in the live chat? Come on. So can I just write this? Y is equal to u sine of theta multiplied by this t. What is the value of this t? That is nothing but this x upon u cos of theta minus this 1 by 2 and g, instead of this t square, that will be x square by this u square cos square of theta exactly. So I'll just write y is equal to this one, that is u sin theta by cos theta, that is tan theta. U will cancel, sin by cos is tan, so that is x tan of theta over here, x tan of theta over here. Then it will be minus 1 by 2 g x square upon this u square cos square of theta. This is the equation of trajectory. Okay, fine. Now see, y is in terms of x only. Understand, we eliminated this t. So y is equal to x square. Understand, y is equal to x square. When this happens, x square, so there is something parabolic graph. There is something parabolic graph. So that means this is the parabola. Okay, let's go for this equation question. So I want you people to tell me what is the answer of this question as soon as possible. A option, B option, C option. What is the option? Correct option. I just need to know in the live chat, all of you. Come on. Which option is correct? The trajectory of a projectile in a vertical plane is given as y is this, where alpha and beta are constants and x and y are respectively the horizontal and vertical distance of the projectile. The angle of projection theta, find maximum height. You need to find basically the theta, understand, and the maximum height. Come on, I just need to know in the live chat over here. Option A, B, C, D. Which option is correct? This was asked in JEE Mains 2021 recently. Okay, this is exactly on the equation of trajectory that I told you. This equation of trajectory. Just 2-second question if you know the concept. Come on, waiting for your answers, man. Listen to me very carefully, okay? I have no expectations on you. You will not solve it. That's why. Say the wrong answer, okay? A, B, C, D, at least guess. Come on. Okay, so it is saying that the trajectory of a projectile, we have launched a projectile. Its trajectory, understand? It's basically equation of trajectory is given as this one. This is the equation of trajectory. Some projectile is launched from this point to this point. Its equation of trajectory with what rate y is changing with x, that is basically given as this one. Where alpha and beta are the constants, okay? This and this are constants. This is in the xy plane. It is saying that at what angle we have launched that. For example, we have launched this projectile, something like this, okay? It's this equation of trajectory is y is equal to ax minus alpha x. This is alpha x minus beta x square, okay? Alpha x minus beta x square has to be over here, I guess. Yeah, beta x square, exactly. So what we are supposed to find over here is we need to find at what angle we need to exactly launch this. What is the value of this theta and what will be the maximum height, with at what height it can, maximum height it can exactly go. Come on. Okay, people saying B, people saying B. B. Let's see what will be the answer exactly. 4 alpha. Let's see, are the options correct or not? This alpha square beta, yeah, I guess. Okay, what is the answer coming out? Is it messing with your mind? Okay, fine. Let's see. People saying exactly B. Let me just show you what is the correct answer. See, if we say, for example, what is the equation of trajectory, you will say y is equal to, that is nothing but a alpha x minus beta x square, exactly. This is the equation of trajectory. If we compare it with the normal equation of trajectory, that is what? Y is equal to x tan of theta. Y is equal to x tan of theta minus 1 by 2 g x square by u square cos square of theta. Is it correct? U square cos square of theta, exactly. Now in this case, if you compare these two, over here, x, so what is the value of alpha over here? Can I say that is tan of theta? So alpha is clearly, that is nothing but tan of theta. We need to find the value of theta. So what will be the value of theta? That is nothing but, theta is nothing but tan inverse of alpha. This cannot be the correct one. So this can be tan inverse of alpha. This cannot be the one. Understand? So we got the value of theta. So first, now we need to find the maximum height. So this is the maximum height, basically this, and this. Let's check for the maximum height. Now, what is the formula for maximum height? So h is equal to nothing but u square. Arey kya tha yaar? Formula for maximum height, that is u square sine square of theta by 2g. U square sine square of theta by 2g. U square sine square of theta by 2g, exactly. Okay, yeah. So can we basically write it something like this? If we compare this with this one, yeah, we can solve. So now sine square of theta by 2 and u square by g. We'll keep it as it is. Now, if you compare this equation with this one, can I say beta over here? This is x square. Beta is equal to this term over here, 100%. So beta is equal to, that is nothing but g by 2. This beta is equal to, that is g by 2 u square cos square of theta. Cos square of theta. Fine. Now take it over there. We'll find the value of this g by u square by g. U square by g from this one, and we'll put it over here. We'll get the maximum height. So take it over there. So it will be u square by this g is equal to nothing but, that is 1 by 2 beta cos square of theta. Cos square of theta, exactly. Fine. So this is 1 by 2 beta cos square of theta, exactly. Now take this equation, so h, so can we just write this? H max is nothing but what it is, that is u square by 2g, this sine square of theta by 2, sine square of theta by this 2, and this u square by 2g. What is the value of u square by 2g? We got it. That is 1 by 2 beta cos square of theta, exactly. So it will be 4, it will be 1 by 4 sine square of theta by cos square of theta. So can I just write a tan square of theta, exactly? This is a tan square of theta upon this 4 beta. Now what is the value of tan of theta? Tan of theta is nothing but alpha. So I can just put it over, that is alpha square by 4 beta is coming out to be the maximum height. This is h max, exactly. So theta was what? What is the value of theta? Tan inverse of alpha. Tan inverse of alpha. Maximum height is what? That is alpha square by 4 beta. Alpha square by 4 beta. I guess this is the correct answer. So this cannot be the one. This cannot be the one. Alpha square by 4 beta tan inverse of alpha. Okay. No, ऐसा नीट में नहीं आएगा. Okay, understood? You got the feel of this question? You understood? No, it is not that lengthy, okay? Just it needs basically how you can exactly think about this question. You need to use the concepts exactly properly. This is a very good question asked in JEE Mains 2014. A bullet fired from a gun, a target placed C. So basically we fired this bullet from a gun. The target is exactly over here. Okay, this is the target. Understand? So it is directly shooting like in this direction. Fine. Now, when this bullet is fired, at the same time, this is released from this one. The target will basically, it starts falling from this point, this height. It starts falling from this height and it will reach over here. Understand? So when it reaches over here, the bullet exactly hits this over here. So what is the direction of bullet initially? It is directing towards the target. So when this target started falling, this bullet will basically, gravity will pull this bullet in downward direction. So this bullet will exactly go down, 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 and it will hit this bullet over here. This is an example of projectile motion also. Understand? Horizontal projectile in this case. So can I say it like that? So we need to find this displacement at what height, at what is the distance between these two? that we need to find exactly where the bullet will over hit. Can you tell me what is the option in this case? And this distance from this point to this point is given at 700, not 100 meters. This is 700 meters, okay? 630 it is meeting. You'll say, sir, why will it hit it over here? See, it is common sense. This bullet is, gravity is attracting this bullet, so it will fall down. So exactly, it will hit it over here. Come on, we need to find this. We need to basically find this one, S. Simple, it is very simple. I'm waiting for your answers. Come on. Come on. A, B, C, D, which option is correct? See, simply you use this formula, okay? Use this one. S is equal to Sy. This Sy you need to find Uyt plus 1 by 2 Ayt square, okay? From this point to this point. Now, in this case, if you use directly in order to find this Sy, you will say, sir, we don't know this time. Understand? We don't know this time. Initial velocity we know. It is released from rest. So Uy is basically 0. So Uy we know. Acceleration in y direction we know. Ay is nothing but a minus g. We know, but we don't know the time. If we'll get the time, how much time it's going to take from this point to this point, we can find how much a displacement. This is how much distance this is exactly. Now, in order to find this time, you need to consider the situation of this gun, this bullet. Now see, how much time this bullet is gonna take from this point to this point. It will take exactly the same time the package will take from this point to this point. Why? Because this bullet is exactly meeting this package. It is hitting this package. It is hitting this target over here. Understand? It is hitting this target. So when this was released from this point, same time the bullet was fired. So it means that the time this bullet is going to take from this point to this point, same this will take from this point to this point. So if you get the time from this point to this point, that means the time, that time is from this point to this point. Put it over here, you'll get the displacement. Let's see how to find that time. So use the same equation in horizontal direction. So that is what? Sx is equal to uxt plus 1 by 2 axt square. Okay, now Sx, how much from this point to this point, how much is this one? Understand? So this is nothing but 700 meters is given. Initial velocity, that is 630. Time is that we are supposed to find. Plus 1 by 2. Acceleration in x direction, that is 0. We know in this case, so it is 0. So it will become 0 only. So it is, okay, this is the 2 of this one. So can I just write in this case, this t will be nothing but 700 by 630. This will cancel. It will be nothing but 10 by 9 seconds. So this bullet is going to take 10 by 9 seconds from this point to this point. So means this target will take t is equal to 10 by 9 seconds in falling from this point to this point. Now put it over here. So Sy is nothing but Uy. That is 0. 0 into t, this becomes 0. 1 by 2. You take this as negative. Then you have to take this also as negative. Okay. Negative, negative will get cancelled. Ay, that is 10. G is nothing but 10. 10. And this is nothing but multiplied by t square. That is nothing but 10 by 9 it square. So Sy is nothing but this is 5. So it will be 5 into 100 by 81. Sy will be something like 6.1 meters. There is no option 100 meters. 6.1 meters. Check it. Okay, check it. Question, this one asked in JEE Mains 2013. Come on. Instead of 7, it is 100 meters. I told you this is 700 over here, 700 over here, okay? In that case, you take it, okay? Consider it 100 also. In JEE 2014, it was 700 was asked. Understand? So you can take it basically according to that. If you take it 100 also, you will get the Concept is exactly the same. Okay, whatever the answer comes, the concept is same. Take it 100, solve it according to that, answer will come out to be the same. Just you need to basically follow the concept. That's all. Now, can you solve this question? A projectile launched with a velocity of this u. Find the equation of trajectory. Which this one. What is the equation of trajectory if the projectile is launched with this velocity? Come on. Waiting for your answers. Means, see, the projectile is launched with a velocity of what? This is a projectile. It is launched with a velocity of this I cap plus 2j cap. This velocity u is nothing but I cap plus 2j cap. Okay. You need to tell me what is the equation of trajectory over here. Means with what? See, y, relation of y with respect to x. Understand? Y in terms of x. Y as a function of x we need to find over here. Let's find x. Let's find y. We'll get the answer. Okay. So how can you exactly find this x? Simply use this. Sx is equal to uxt plus 1 by 2 axt square. And how can you find y? Sy is equal to uyt plus 1 by 2 ayt square. Fine. So from here you'll get the x, from here you'll get the y. Understand? So once combine both of these, you'll get the answer. Now in this case, can we find this x? It's very simple. You'll say, sir, x is nothing but, instead of this s, we'll write x. I'm using this equation in a horizontal motion, horizontal direction. So x is nothing but initial velocity in x direction. This is initial velocity initially. So in x it is only, this is I cap. So means in x it is 1. It is 1. Understand? This is 1. In this y it is nothing but 2. It is nothing but 2. So can I just write x, that is t only, plus 1 by 2. This becomes 0. Why? Because acceleration in x direction is 0. 1 by 2 into 0 into t square. So x is equal to t. We got this one. Fine. Now find y. Y is nothing but initial velocity in y direction. You'll say, sir, initial velocity in y direction, that is 2. Because that is 2. So can I just write this is nothing but 2t plus, instead of this plus, I'll just write minus, because 1 by 2 acceleration is minus g. So this will be minus g, or you just write 10, minus 10. Okay. And this t square over here, this will be 5. So y is equal to t minus, this will be 5t square. Now you need the equation of y in terms of x. So x is equal to t, put it over here. So y is equal to 2 into x minus 5 into x square. So this y is equal to x minus 5x square. So which option? 2x minus 5x square. Let's go for the next one. Thank you, Karthik. Come on, this is the next question that we have. A projectile is basically launched. Its velocity at a point is v is this. Find initial velocity and angle of projection. Can you tell me? It is saying that we have launched a projectile, okay? This from this point to this point. At some point, its velocity is what? This, that is 30i. This v, at some point, the velocity is 30i plus 40j cap. You are supposed to tell me with what velocity it has launched initially, this u, and you are supposed to tell me what is the value of this theta, angle of projection. Can you tell me over here? Just let me know in the live chat as soon as possible. Come on, in this one. Okay. What is the basically rule that we can exactly use in order to find this one? See, we know the final velocity. If we want to find the initial velocity, same old method that I told you previously. See, you need to find this initial velocity. Now, if you will get the initial velocity's x component, that is ux. If you will get its y component, that is uy, you can find this. That is root of this ux square plus that plus uy square. If you'll get this, put it over here, you'll get the value of this. How can you exactly find this? I just need to know. See, this, if I talk about this one at this point, what is the velocity in x direction? That is vx. That is nothing but this 30, because this is the x component. What is Vy? That is this 40. This Vy is nothing but this 40. Fine. Now, if I ask you, thank you. If I ask you in this case, could you please tell me this Ux? So you will say, sir, this Vx is equal to Ux is nothing but how much? That is 30 meter per second. Why? Because acceleration, velocity in x direction remains same because there is no acceleration, previously discussed. Okay. Now we need to basically find this one, this another one we need to exactly find over here. That is one. U initial velocity in y direction. Y direction velocity changes, so we need to exactly use the formula over here in order to get that. Now see, if we want to find, use this one, Vy square, and this is exactly given over here. I forgot to tell you, this is 45 meters. Okay, so Vy square minus Uy square is equal to 2as. Fine. Can I say final velocity in that case is how much given? That is 40, because over here Vy is how much? 40. So this is 40 square minus initial velocity in y direction. So that we are supposed to calculate initial velocity in y direction square is equal to 2 into this acceleration is how much? That is minus 10. So I'll just write minus and multiplied by this 10. This 10 multiplied by this, how much is this distance? That is 45 meters exactly. So this minus will cancel when we take that 45 over here. Okay. Can you tell me how much it will be exactly? So we can definitely write it like that. See, I want you people to tell me how much this will be. So this Uy will be, I guess it will be something like 50. Okay. This 50, if you calculate this one, so this Uy will come out to be this 50. Okay. Uy come out to be this 50. This Ux is basically 30. So if you put it over here, this U is this Ux square, that is how much? 30 square. You check it. Okay, how much it is coming? So this 30 square plus this 50 square exactly. So U is nothing but root of 30 square. It is nothing but 900 plus. This is 2500. U is nothing but, that is root of 3400. U is nothing but, we can write it 100 multiplied by 34. It is nothing but 10 root 34 meter per second. Initial velocity in this direction. Initial velocity in initial velocity. Now, theta will be nothing but, you will say, sir, that is tan of theta. In this case, initially tan theta is nothing but this perpendicular by base. That is nothing but how much? You will say that is Vy, Uy by Ux. How much is this Uy? 50 by 30. This cancels. Theta is equal to tan inverse of pi by 3. Check if the calculation is correct. Okay. Rest everything is okay. Okay. That's great. Now this is the question that is homework. One of the beautiful questions. I want you people to solve this one. This is not the JEE mains level question. This is JEE advanced level question. Okay. This is JEE advanced level question. I want you to solve this. I'll be showing you in the next class. So I want you to basically put the answer of this question in the comments down below. Okay. So this question is basically saying that there's, okay, you just read it tomorrow. I'll tell you the answer of this one. This is homework. And drop the answer in comments down below. Fine. Thank you, ladies and gentlemen. It was all about today. Okay. What happened? What happened, Khushi? What happened? Questions were difficult today? You feel questions are difficult? Okay. They were having a very good level. That's why it was mentioned in the thumbnail itself. Projectile motion with the killer problems. Yeah, not difficult, but challenging. Yes. Yes, you need to basically practice this. Okay, ladies and gentlemen. So, boys and girls, apart from this YouTube platform, we have our own platform, that is Unacademy's platform. Okay, over there, country's top educators are teaching you. Okay, you get, if you get this plus subscription, then only you can learn from those top educators which are from quota, which are from entire country. Okay, so live classes will be getting their weekly test, structured courses, unlimited access. And if you take this iconic subscription, in this iconic subscription, you'll be getting all of these features. And apart from these features, you'll be getting some extra benefits as well. That is this: personal guidance, test analysis, experts guidance, study material, study planners. This personal guidance is basically an educator will help you throughout your exam. Whatever you need, he'll guide you. Understand? He'll give you, you'll be getting a branded study material. That too will be delivered to your doorstep. That too in the hard copy. Okay, you don't have to read from the soft copy. You'll get that bookish feel. So from this one, some study planners, you'll be getting experts guidelines, test analysis. Once you are done with the test, afterwards you need to analyze where you are lagging, in what portion you need to work more. So that is done by our experts only. Okay. Now, if you want to follow me, you can definitely follow me on Unacademy. This is my username over there, Yawar Manzoor. You should definitely go for this one. Fine. Now, these are the upcoming batches which are launching very soon on Unacademy. I suggest you to take any of these. Now, you people are basically looking for the batches that is completely in English. So this Shine 2.0 is launching for class 12th, JEE Mains and Advanced 2022. So I suggest you to enroll in this one because this is completely in English language. Okay. Previously also we have launched Shine 1.0 and Spark 1.0. And you can take this plus subscription for 3 months, 6 months, 12 months, 18 months, and 24 months. I told you what are the benefits you get in plus. And if you take it for 3 months, the price will be 17,000 some hundred. Okay. And if you use my code, it will be only for 14,000 some hundred. Okay. Maximum possible discount. So for this 12 months also, it'll get for this much of price. If you want the maximum possible discount, you can definitely get it in this one. Now the point over here is, see, are the EMI options available? Definitely yes. You can pay it every single month. You don't have to pay the entire amount at once only. You can pay it every single month, monthly also. Okay. So this is the price for 18 months. By using my code, you can get the maximum possible discount. For 24 months, this is the price. You can get definitely the maximum possible discount from this one. Same goes for Iconic. This is for 12 months. This is for 18 months. This is for 24 months. Okay. So this price, this is the price. This is the price. If you use my code over here, you will get a lots and lots of discount from this price also by using my code, And if you are aiming for JEE 2022, there is something very very much coming up for you. Now, this is one of the beautiful features on Unacademy right now. Thank you. Okay. And this is one of the beautiful features on Unacademy right now. That's Ask a Doubt. Okay, if you have any sort of doubt, you can post it on Unacademy, provided you have that plus subscription. Unlimited doubts you can ask. You'll be getting the solutions, that too in the video format. Understand? Our educators are waiting for you people. You'll send the doubts and you'll get that too in video format. You can ask anytime that doubt. Understand? And you will get the correct video solution, 100% correct. Now, the question is how you can ask that doubt. We have this doubt and solutions option on Unacademy. You have to click on this one. After that, you need to select what doubt exactly. You would take the picture of that one. And that picture should not be blurred. It should be clean, crystal. Okay, so that our educators will be able to see it, so that they can give you the correct answer. Make sure you crop that doubt only. You should not send like in a single picture 5 to 6 questions, so that our educator will be basically confused which concept I have to explain, which question I need to solve. So that's why on that particular doubt you need to basically encircle or crop, and we will be sending you the solutions within no time. And these are the rules and protocols that you need to follow exactly while you go for this Ask Me Doubt. Thank you so much. It was nice interacting with you. Thank you so much, everybody. Bye-bye. Boy. Yes, see you tomorrow. Okay, and I want you people to subscribe to this channel, hit the bell notification, like this video, comment this video before you leave, and do let me know in the comments which part was the exciting one. Thank you so much, ladies and gentlemen. Take care. Bye bye. See you guys very soon. Thank you so much.